Hello friends, so today in this video we're going to discuss the first problem from the latest code jam round 1C. The problem name is closest pick. I actually solved this during a contest. I just got two wrong summation and then I solved it. So I'll tell you the problem statement. It actually states that you are having n tickets. Like actually there are n tickets in some contest you can assume, and every ticket has an integer written on it from 1 till k. And every ticket has inclusive 1 to k, like any one integer is written on every ticket. Now you know that what number is there on each ticket. Okay, now you have to choose two tickets. Okay, now you have to buy two tickets, not among these n tickets. You have to buy some another two tickets which should also consist number from 1 till k. So now there are n tickets sold which has number from 1 till k, and now you also want to buy out two other tickets which have a number between 1 and k, such that you want to maximize your chance of winning. Now how this game is actually played, it's like a lucky draw. So it's like one number is after the competition is over, as you have seen, like now n tickets are sold, so you know that what is the number on each ticket, and you have to also choose two numbers such that you are the last person to choose the ticket. Now after you have chosen the ticket, after you have chosen two tickets, like there is a random number which is picked between 1 and k, and among that number you have two numbers and there are another numbers with n numbers on the tickets. So whatever ticket is as close to the number which is randomly picked, that will be the winner. So if your, as you can see, it randomly picked, if one of your tickets it should be strictly closer to C than all the other tickets, then you will win. So you have to find out that you want to maximize your probability to win. Okay, so what is the maximum probability for you to win if you strategically choose two integers among all the numbers from 1 till k, such that you have the maximum chance to win? And that's the whole problem. So so in this problem, what you can easily see here is, first try to draw out this example on a number line, because you want to find out the closest number so that you have the maximum probability to win. So it means that it's some sort of distance thing. So try to draw it on a number line. Okay, so as you can see in the first example, there are three tickets, 1, 3 and 7, and among all of these tickets what you can see here is let's wait. Yes, so as we can observe from here is that if you choose out now in this problem, in the first example, you have seen that there are three tickets which are already sold with the numbers 1, 3 and 7. Okay, so now you can draw that 1, 3 and 7. So maybe 1, 2, 3, 4, 5, 6, or let's assume that let's draw it again so that we can match it out easily. So as you can see, this is the number line: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the first ticket is sold, the third ticket is sold, 3, 4, 5, 6, 7, the seventh ticket is sold. Okay, so these tickets are somehow sold, and now you actually want to buy two tickets such that you want to maximize your chance to win. Now what you can observe in this problem is, let's see the example only, what number they have chosen. If you choose the number 4 and 8, okay, if you choose the number 4, this is the number 4, 1, 2, 3, 4, 5, so this is 6 actually, 1, 2, 3, actually 5, this is 5, this is 6, this is 7, 8, 9 and 10. If you choose out this 4 and 8, then what are the numbers? If 1 will occur, then you will lose, because 1, this ticket is as close to 1, so you will lose, because you have to somehow find out a number. If you have chosen these tickets, then only you will win. What is the probability? You will see. Okay, so in this case you will lose. In this case you also lose, because this number is close to this number, which means that if the lucky draw find out that the lucky draw number is 2, the lucky draw number is 2 and the tickets you have is 4 and 8, the distance between your closest number to the lucky draw number and the other tickets, if the other tickets is having a distance smaller than your distance, your distance should be strictly smaller than, okay, then all the other distances, then only you will win. So in this case also you will lose for 2. For 3 also you lose, because there's a ticket on 3, so this distance is already 0. But now if the lucky draw number is 4, then you will win, because you have a number ticket which is 4. For 5 you will win, because see, for 5 you have a ticket, like because you have a ticket of 4, this is closer, and there's the next closer ticket is this, which is a distance of 2. This distance is 2 and this distance is 1, because if the lucky draw number which is come out is 5 and you have a ticket of 4 and 8, then as you can see that like this distance is closer, so obviously like you will win. For 5 you will also win. For 6 you will not win, because see, for 6, like though the distance between this is 2 and the distance between this is 1, so like this distance is greater than this distance, so you will not win. So 7 you will not win. For 8 you will win, because like there's a like already there is a as you can see a ticket for there. For 9 you will win, because for 9 there's only one distance and the previous card is on 7, so obviously that will be greater. For 10 also you will win. So as you can see, for these of the distance you will win, which is like for 4, 5, 8, 9, 10 you will win. So, and there are total how many cards, like total possibilities is k, which is like 1 till k, which is like 10. So 5 upon 10, which is 0.5. So if you choose out these distances, the probability of your winning is 0.5. So now how you can try to solve out this problem now. So let's delete out these things out so that we can easily see. So now what you can easily observe in this problem is, let's again mark it out, sorry, 5, 6, 7, 8, 9, 10. Now the things what you can observe is, if you choose out or if you take a digit which is already taken, then obviously that's not, like you will not win in that case, because both of them are 0. Like that ticket will also have a distance, so let's assume that 1 will come out, and also you have a ticket of 1, but also 1 is taken, so you will not win, because your distance should be strictly smaller than all the other distances. And obviously there's a ticket at 1 also, so the smallest distance between all the tickets is 0, and your distance is also 0, so it's not strictly 0, strictly greater. So the answer is like you will not win. So it's obviously beneficial to take out the numbers from the rest of the numbers which are remaining. So as you can observe in this problem is like you want to, like, so if this is the places which are taken, the 1 number is taken, 3 number is taken, and 7 number is taken, you can place a number in this, like I am marking out as a as you can see a sequence. So you can take out in this sequence, you can take out in this sequence, or you can take out in this sequence. Like you can take a number between 1 or this 4, 5, 6 or 7, 8, 9, because these numbers you do not want. You can only place a number here. So now if you clearly observe that, if you have taken this ticket, then obviously all the numbers ahead of this are the number for which you will win, because the last ticket is here and you have taken a number which is more than this position. So for all the positions you have a distance smaller than all the other distances, because this is the closest one and that is behind you. So for all the positions you have a better opportunity. So as you can see, if there is some space left before ending, so this is the time, like this is the number line, and the last card has some space here. So this space, if you put a number just before it, then this whole range is yours. Like you can win for every number. So you can just buy a ticket of this number, and then this whole number line is yours. You can win for all this number line. Same can happen before this. There is one at the starting, like you have taken the first digit, but if there's a number line, let's assume that like the first ticket is of 10, so and you have a ticket of 9, so all the numbers between 1 and 9 are yours. So like you can win for that point if you buy a ticket of 9. I hope you get the point. But now for the middle ranges, what you can observe is, in the middle range, it means that in this case there is one ticket but there is no ticket in the end. Like in this case also there is one ticket here but there is no ticket in there. So in that case, if you buy out a ticket at this point, all the numbers are in your range. But in the middle ranges, there is both the ticket at both of the both of the ends. This is a ticket and there's a ticket which is bought. So this is the range which is free. Okay, so as you can see, if I bought a ticket at this point, then the range is of, let's assume that the range is of odd length. Then the range is of odd length. As you can see, three positions are left. If I bought a ticket of this point, I will win for this number and I will win for this number also, because as you can see, this distance is 1 and this distance is 2. So I will win for this position also. So if the distance, so I have to find out these intervals, these interval lengths. As you can see, you just sort out all the positions of all these tickets and then find out the interval lengths. Okay, if the interval length is of odd length, as you can see, if you have odd length, so if you buy out a ticket at this point, so the number of positions you will win is the length divided by 2, like the seal of it. So 3 divided by 2, seal of it, so it is equal to 2. And if the length is odd, like even, if there are 4 positions, so if the ticket is at there and it is at here, and for the first position you will win, the second position you will, but for the third and fourth position you will lose. You can check it on our paper. So as you can see, thus for even also, if you find out a seal, it is fine. 4 divided by 2, the seal is also 2. It means that you have to find out the different lengths of these. Okay, and for these lengths, if the length is odd, then if you take out a ticket at this starting of this sequence or this bracket sequence, sequence, then what will happen that for this point you will have the half of it. For those positions you will win. So you have to find out the maximum. So you have to choose 2 digits, like 2 tickets. But the case at which I actually failed is, there is also one more catch. The catch is, I'll just read it out so that it will become more clear. This is the number line, and let's assume that this is the ticket, this is the ticket, this is the ticket. Okay, so let's assume that this length is odd, this is the odd length. Okay, and if you bought out a ticket, like if you bought out some ticket for yourself at this point, then the half of this you will win, and for the half you will not win. But if you buy the other ticket at this point, like so let's assume that all the other ranges are very small, like the range is 1, 1, like the ranges between 2 tickets are, the tickets is very small, 1, 1. So instead of buying ticket at this point, this one range is very large, which is having 100 positions in between. So I hope you get the way you are imagining with me. These tickets means that whatever tickets are already bought. Okay, these tickets are already bought. So you have to somehow buy 2 tickets for yourself, such that you have to maximize your chance of winning. Okay, if you are buying a ticket for the end and there are some spaces left, then in that case you will get the chance, like the winning possibilities for you is all the numbers like after it or all the numbers before it. Okay, if you buy out a ticket at this position or this position. But for all the middle positions, if you bought a ticket at the starting of this, then the half of this is yours, for which you will win. But you can also see the case here is, let's assume that the middle brackets or middle sequences is very small, but there is only one sequence which is very large, let's assume. Then if you buy out a ticket for this sequence, then you will only get half. And if you buy out another ticket for here, let's assume, then also you will get a small portion. But if you buy out one ticket at this position and one ticket before this card, so there is one ticket at this point and one ticket at this point. If you buy out one ticket for yourself just after this, and one ticket just after this, just before this, so this whole sequence will be yours. I hope you get the point, because see, now one ticket is here which is bought by you, and one ticket is here which is bought by you. So all the positions in between is actually reached faster in the smaller chance by tickets than by another tickets, because they are on other ends. Like this ticket which is bought cannot be reached before you, because there is a ticket after that, and also that ticket cannot be reached because there is a ticket which you have already bought. So this is also a trivial case, like you can watch out. So if the size of the like the bracket or actually the sequence is relatively large, you can just bought out 2 tickets at the end of this sequence, such that like then also you can win. I hope you get the point. So these are all the cases. Then you have to just like write a code for all of these cases, and that's the answer. I hope you understand the like the logic part till now. So we'll go through the code. The code is not too good, like I've written down all the cases, but you can understand it. So this is A for taking out all the numbers. Then you just sort them out. Okay. Then we have to find out the length of the bracket sequences, like whatever is the like not bracket sequences, the difference between the 2 parts. So we start from 1. Okay, and then subtract the ith from the I-1 card. Subtract 1 from it, because we want the length of the length of just the sequence. Okay, and if it is less than 0, we just continue out, else we just push the length of that in a vector B, which will just store the length of these. Now what we'll do, we will find out possible candidates for our